Hello. So in this video, I'm going to be talking to you guys about the purine structures. And so before I get started into the actual structures of purines, just a brief general chemistry note that will help you to draw these structures if you ever have to draw them from memory. Carbon has 4 bonds in order for it to be completely stable. Nitrogen has 3 bonds and oxygen has 2 bonds. So if you're not familiar where I'm getting this bond information from, then you'll need to go back and study some general chemistry in order to understand that. The purine structures, there are 2 of those. Those are adenine and guanine. So this top structure here that I've drawn out with all of the carbon, the nitrogen atoms with their bonds. And I've also drawn out here guanine with, and the difference, one of the main differences between adenine and guanine is this double bonded O, as I have noted here to the side. Some really basic differences between the two, similarities between the two, and then I'll go back to the differences. But some basic similarities between the two is both of them are a 5-membered ring fused with a 6-membered ring. And so that 5-membered ring is this portion right here, and the 6-membered ring is this portion that is here. And the same for here, the 5-membered ring and the 6-membered ring. Another comparison is that the 5-membered ring for the 2 of these are exactly the same. So your differences come in when you're looking at the 6-membered ring. Across the entire molecule as a whole. Sorry about that. Yes, I have a little dog here. But going back to what I was saying, in terms of the whole adenine structure and the whole guanine structure itself, there are 5 nitrogens, so 1, 2, 3, 4, and 5, and then 1, 2, 3, 4, and 5. So that's another similarity between the two, is there's a total of 5 nitrogens. And the last similarity is that both of them have an amine group attached, so the amine group is attached here, and the other amine group in adenine is attached here. What's really important to note that the amine group in guanine is in a different location in comparison to the amine group in adenine. And just as a mnemonic, the way that I remember guanine has this double bonded O is, to me, guan, and I kind of force that into an O sound, guanine. And yeah, so it has that double bonded O right there. And it also makes me realize that if this double bonded O is at this carbon, then that means that this amine group that is in adenine is pushed to another place. So now I'm going to actually draw these structures as I would draw them for a test or just from memory. So I'm going to start off with drawing the 5-membered ring. And the way that just going to start over. Drawing the 5-membered ring. I know there's an N here and an N here, and that N is attached to an H. And so yeah, so here's my 5-membered ring. That's 1, 2, 3, 4, 5 points. Okay, now this is where knowing how many bonds something has comes into importance. So in order for nitrogen to be stable, it has to have 3 bonds. So right now, this nitrogen only has 2 bonds. So I know that I can add that one in there and nitrogen becomes stable. And also you can look about what it's connected to. So this point here represents a carbon, and carbon has to have 4 bonds in order to be stable. So it has 1, 2, 3 bonds. And if we look back here at this structure that I drew of adenine, it has a hydrogen that's also attached off to the side, and I'm talking about this hydrogen right here. So we have our stable 5-membered ring. Now let's go to drawing our 6-membered ring. I know there's a nitrogen here. I know that there's a nitrogen here. No, I'm sorry, there's no nitrogen there. I know that there is an NH2 here. And I know that there is also a nitrogen here. So here is our 6-membered ring. You have 1, 2, 3, 4, 5, 6 points. Now back to checking to make sure everyone is bonded where they should be. This carbon should have 4 bonds. 1, 2, 3. Let's draw that line, make that 4, and then this carbon should have 4 bonds. So that's 1, 2, 3, and 4. So that fills that situation right there. Here, this nitrogen should have 3 bonds. So 1, 2, 1, 2. So let's add that line there, and that makes it having its 3rd bond. And this nitrogen here should also have 3 bonds. So we have that as well. And keep in mind that it couldn't have gone here because here is a carbon, and this carbon is already full with its 4 bonds, because if we go back to this structure here, it also has a hydrogen sticking off of that carbon right there. So here is our adenine structure. Now let's go down here to draw guanine. Ooh, I need a new marker. Okay, so what are the similarities between adenine and guanine? Remember that I said they both have the exact same 5-membered ring. So with that in mind, we have that 5-membered ring, the NH, and it's the exact same. And going into drawing our 6-membered ring, remember it's this guanine, so it has a double bonded O connected to it. And it also has 5 carbons on it, so just keeping that in mind as well. Here also 1, 2, 3, 4, 5. Check, we have those 5 carbons. I'm sorry, 5 nitrogens. And if we come here, I know that there is a nitrogen here. I also know that there is a nitrogen here. So remember, we said that there's an NH2 group on both of these, but they're changed. They're switched from the location in adenine to a different location in guanine. And so here is where the NH2 goes. And let's go back and check and make sure that everything has its correct amount of bonds. So nitrogen, this is actually an NH. So that gives for its 3 bonds. We come here and we have 1, 2 bonds. So we're missing a bond here. And if we look at this carbon, it only has 1, 2, 3 bonds. So to fulfill nitrogen's nitrogen's bond requirement and carbon's bond requirement, we're going to add a double bond here. And that gives us our 2 adenine and guanine nuclear base structures.